Hello everyone. In this video I'm going to talk about the use of a Google spreadsheet in your gauntlets to help us model our labs. So I'm in Google Drive right now and I'm going to create a new Google spreadsheet and show you the steps you're going to use to create this Google spreadsheet model. So I'm going to click New for New Spreadsheet here. New Sheet. Okay. And what I get is a spreadsheet. If you've never used a spreadsheet, a word processor is to use to process words. Spreadsheet is like a number processor. You can use it to input numbers, text, or equations and do some calculations with it. So it's like a calculator. So first thing I'm going to do is I'm going to actually click in this cell above the intersection of A and 1 and kind of increase the font size, give me at least 12 points here for my text. This is going to be Gauntlet 1. So I'm going to say in the untitled spreadsheet area, say Gauntlet Task 1. Okay. So I give it a name. So a couple of things I want to do is I want to give it a title again, Gauntlet Task 1. This is the Usain Bolt Gauntlet. And put your group members' names down there. So Lou and your other students or group partners in there. And then I'll skip a line here. And so what I'm going to do is I'm going to have 3 different sections. I'm going to have input values for all the variables that you're going to use in the particular lab. So we're going to input them. So I'll say this is input section. Okay. And for the lab here, we're going to use what's called the kinematics model. And I'll demonstrate this in class. We're going to have something called x0 for initial displacement. X. Okay. V0 for initial velocity. V. Acceleration and time. Okay. And right now I'm just going to give some arbitrary values, 0 and 1, and let's say you start from 2 to 5, and this is 6, and we want to know times that we're trying to find in one of these sections. Displacement or position is in meters, we put our units there. Same thing for final position. Velocity is meters per second. Velocity, ending velocity is again meters per second. Acceleration is meters per second squared, little caret there, caret symbol. And then finally, time is in seconds. We want to make sure per units there. I'm going to add some border. We'll click on the border button. Click on this little border there. And input section. I'm going to actually expand it and have it merge through all three columns there. Merge it, and then give me a little color there so I can easily see it. Okay. So these are my input values, and these are values I'm going to get from my lab. The second section is called the processing section. And this is where all the calculations are done. So in this particular lab, we are going to actually have some values for position, velocity, and acceleration, and our goal here is to find the time. So I'm going to pull up an equation here. You wouldn't normally do this, but I'm just going to pull it up so you can see what equation I'm working with. I drag one that I've created. I'll upload here in a second. Okay. And you'll see the equation right over here. So, in this particular, oh, I can't move it. Put it over here. Insert image. Go to the other section here. I'm going to use this equation. There it is. And one of the kinematic equations you're going to see is V is equal to V0 plus AT. If I know my initial velocity and I know my acceleration rate and time, I should be able to find my final velocity. In this particular case, I'm going to actually solve for time. So if I have this equation here, which is my basic kinematic equation, and I solve for time, I get V minus V0 all over acceleration. So this is what this is for. I'm going to actually use this spreadsheet to calculate the value of t. So I'm going to say t. Now this is an equation. So I'm going to start with equals parentheses v. So I click on the value for v minus v0 close parentheses all divided by the acceleration rate, as you can see here, which is a, and I get an answer. Okay. Now the really nice thing about this is that when you do these gauntlets, you're going to be trying different scenarios and changing velocity. So if I change this to 2.7, then I get a new answer. Make sure I have my units here. Okay. If I change my final velocity, 7.8, I get a new answer there as well. So that's my processing section. merge the cells, give me a little bit of color here so I can easily find it. Okay, and then the last section, some borders. The last section is the tolerance level. So in each lab you have, or Gauntlet, you have an exact answer you're trying to look for, but I always usually give you a tolerance level, plus or minus 5%, plus or minus 2%, what have you. So here I'm actually going to do the calculation for the plus or minus 5%, so if you can see if your answer is actually inside the window. So I'm going to say single quote plus 5%. I put the single quote there so it doesn't think I'm trying to do a mathematical calculation. I'm just trying to write text. And then single quote minus 5% if the tolerance is 5%. So then what I can do here is write the equation for 5% more than that. So equals 1.05 times 0.85. So my answer can be as high as 0.8925, or equals 0.95 times the 0.85. So my answer can be as low as 0.8075. So the really cool thing about this is as I go through and I change values, let's say this is 3.4 in a different trial, not only does my answer change, but also my tolerance level changes. So I can see, put my units here, if what my window for values are with the new input values. One last thing here is I will actually highlight these numbers, those values for numbers, and I'm going to say format number, and I'm going to give myself number, here are the couple decimal points. I'm going to go do it again here because I have quite a few. Format number, like that, and I'll highlight these two as well. Format number, right there. Okay. Again, give me, this is a nice little button here. If I have an existing cell that's nicely formatted, I want to just copy that over to this here, I can just hit the paint button and click and drag to get that all formatted. Give myself some borders there, and there you go. So this is an example of a Google spreadsheet model. Again, the purpose is for me to be able to quickly calculate not only the value I'm looking for, but also a tolerance level. In this case, it's a very simple calculation, but again, in some other labs, you may have simultaneous equations, so the number of calculations can be somewhat complex or complicated. Once you type it into the spreadsheet, by changing values, the input values, to the equation, you can very easily and very quickly calculate final values and tolerances levels. Acceleration 5.5, and you can see the values change. Okay, so that's a simple example of a Google spreadsheet model that you'll be using in your gauntlets.